Here's number 35 from the from section 9.1. We're talking about each of these diverging in a slightly different way. Let's look at case A. We can look at this as the sum of 2 plus 2, or 2 plus 4 plus 6 plus 8. And it's clear to me that the limit as n approaches infinity of the nth term of this series does not equal 0. And because of that, it's got to be divergent. Now, another way of looking at this in terms of partial sums, we could say s of 1 is 2. S of 2 is equal to 2 plus 2 is, or 2 plus 4 is 6. S of 3 is 6 plus 6 is 12. S of 4 is 20. And this particular series, or called the triangular numbers, is actually predictable for it's related to the triangular numbers. S of n is actually going to be something like n plus 1 divided by 2. That's the triangular numbers, but we have twice, the numbers are twice as big, so multiply that by 2. 2's cancel, and that's like, so this is 1 times 2, this is 2 times 3, this is 3 times 4. And clearly the limit as n approaches infinity of n times n plus 2 is infinite. It does not diverge. So there's one way of attacking case A. In case B, the series looks like 1 plus a negative 1 plus 1 plus a negative 1. I think we did this in class. The partial sum is 1. Partial sum 2 is going to be 0. Partial sum 3 is 1. Partial sum 4, when we take another negative 1, goes back to 0. And so the limit of the partial sum here, as n goes to infinity, doesn't go to any particular value. It oscillates back and forth between 1 and 0. And so therefore it diverges. Or I should say the limit does not exist, and therefore the series diverges. And then C has both of these characteristics. The partial sum, well, the series is equal to 2 minus 4 plus 6 minus 8. Partial sum 1 is 2. Partial sum 2 is going to be negative 2. Partial sum 3, when I add 6 under that, is going to be 4. Partial sum 4, when I actually subtract 8 from that, is going to be negative 4. And you can see I'm just going to be bopping back and forth between these, they're alternating back and forth between plus and minus. Partial sum n ends up being negative n if n is even, and it ends up being n plus 1 if n is odd. In either case, the limit as n approaches infinity of the partial sum does not converge. This limit does not exist, and so the series does not converge.